we have the following x, which is not inside the square root. Can you see that one again? So this one is outside the square root. So I'll say I'm coming to write this one. It's to the power of 1 multiplied by. So if you check this x here, it's inside how many square root? It's inside 1 square root. So I will say, okay, I'm going to write this as, this is the x, and then I'm going to write this thing here. I come and check what does it have here. So there's a difference between something like this x root, and then there is x, then there's the root. This is x multiplied by the root. So this is x multiplied by the root. So those are two different things. And then if we want to change a root and write it as a rational exponent, how do we write it? We write it as 1 all over 1 all over 2. Okay, so this is this part, okay? And then I'm going to go to this one is this part. Okay? Multiplied by, I have this one now. Does that make sense? So this one, I'm going to put it again. I'm saying I may have x. But now, how many roots does this one fall under? So it falls under this root first, okay? So it's going to be 1 all over 2 for that root. Again, I'm going to open another root. And then it's going to be 1 all over 2. So it's for this root and this root. Huh? 2 all over? 2 all over 2. No, we can't write it as 2 all over 2. We can write it as 1 all over 2 multiplied by 1 all over 2. So we can write it as a quarter. So we can say, instead of writing this, we can write it as x to the power 1 all over 2. Meaning that we have two roots. We have root and root. So it's a quarter of a root. Multiply by. So we're going inside. Okay? So if we check this one, how many roots does it have? It has 1, 2, 3. Né? Now, if we want to use the principle that we spoke about here, we can say this can be written as, as x to the power of 1 all over 8. How did I get 1 all over 8? I had 2 multiplied by 2 multiplied by 2. And then it's 1 all over 8. But now, if we don't want to write it that way, we're going to say we have x inside. Okay? Now, how many roots do you have? This is root number 1, 1 all over 2. Root number 2, 1 all over 2. Root number 3, 1 all over 2. Then now you have 1 all over 2 multiplied by 1 over 2 multiplied by 1 over 2, which is going to give us what? 1 all over 8. Are we still together? Yes. Okay. Yeah, these are some of the examination questions that we can get. If we look at the last one, we can say, okay, we have x, which is this one again. Now, based on what we said, if you want to write it this way, we can say it's 2 multiplied by 2 multiplied by 2 multiplied by 2, which is going to be x to the power of 1 all over 16. Okay. Now, if we use the principle that we're using above here, we'll say, okay, we have x. Let's put x in. So we have the first root. You use this root. Get this one again. We go to the next root. Get this one. It's 1 all over 2. One all over 2. This one, done again. How many do we have? 1, 2, 3, 4. So we have 1, 2, 3. So we have the last one here. 1 all over 2. Then we close the bigger bracket. And then we are saying, instead of writing this thing that way here, I'm just showing you which this is the top part. Okay? We could have said, okay, this is all over. We'll come back to that. We know that this and this is exactly the same thing. So we'll say, okay, in the denominator, we have all over. Here we have 30 inside. Okay? So we have 30 inside. So we'll write first, open bracket, x to the power of 30. Outside, what am I writing? Is 1 all over. So it's 1 all over 16. And then from here, it's going to be raising a power to the furthest power. So here I have this one multiplied by this one. This one, it's x, it's fine. So I have x multiplied by this one multiplied by this one. 1 multiplied by half. Multiplied by a quarter, x to the power 1 all over 4. Multiplied by We're multiplying it again. So it's going to give us x to the power 1 all over 8. Multiply by, we have x to the power 1 all over 16. All over. This one, okay, we're raising a power to the first power. Okay? So you have 30 all over 1. If they didn't write anything, so it's all over 1. So when you're multiplying fractions, it's numerator multiplied by the numerator, denominator multiplied by the denominator. And then in this case, it says that we have, in our denominator, we're going to have x to the power of 30 we have x to the power of 30 all over 16, like this. Okay, now we have laws of exponents when we are multiplying. Okay? When you multiply powers of the same base, what do? So our exponents, which we add them. So let's add the exponents. So we have 1 plus 0.5. 0.5, it's okay, let's do it that way so that you don't complain and say, Marase, where does that one come from? So we have 1 all over 2 plus 1, 4. 1 all over 8. No, we're not done, man. Shut. 16 is missing. Okay. 1 all over 16. Now we're done then. Then if we say we get 31 all over, so we'll come and write this thing as x to the power of 31 all over what? All over 16. Here you have x to the power of 30 all over what? All over 16. Now, if we are dividing powers of the same base, what do we do? What is that? What is the law? We minus. So it means we should take this thing up again. When we take it up, it's going to be minus 30 all over what? All over 16. Then we can come and erase it here. So it's no longer there. Now you can guess now what is going to be. It's going to be x to the power of 1 all over. Are you sure? Okay, then this is going to be our final answer. 1 all over 16. Are you sure, guys? Okay, let's say equals to. So we have minus 30 all over 16 here. It's 1 all over 16. All right. Then it means if we are able to talk about that, then we can do this one.